So welcome back to this first session on optimization, which is basically introduction to optimization. Now let's see what is optimization. Optimization, we normally talk about optimization in daily use, daily life also, day-to-day talk also, and we as engineers have special significance of this word optimization. We normally say that we have to optimize the resources. So what is the meaning of that? Optimization is basically a mathematical term in terms of some equations and all. But what we talk is, we will talk about engineering optimization. Engineering optimization is basically optimizing the resources to get the best results where more than one variables are affecting the outcome. Right? Now let's say, take an example. Let's say you have a new plant coming up, new factory coming up. You want to arrange the equipment in the plant. Now what I want to do, I want that there should be a minimum movement of parts from one machine to other machine. The distances traveled should be minimum, or the time taken to travel should be minimum. Or I want to optimize the sequence of operations on a component, so that the throughput time for manufacturing that component is minimum. So that, because I'm from mechanical, so I'm giving a mechanical example. Let's say you want to arrange the, let's say you have a CPU, you have a microprocessor in the computer. You want to arrange the components in the microprocessor, I chip only. So it is similar to our plant layout situation, where you have a large number of components and you have a limitation on space, where you want to minimize the some criteria, or you want to maximize some criteria. So optimization is basically a combination of some resources, some input factors to maximize or minimize the output. That is the engineering definition what I have. It may not be a textbook definition, but it is practically what we want from optimization. You, because you are from different disciplines, you can have different examples in your life, in your day-to-day working. I want to optimize the expenses in my household. What are the items I want to buy, so that I can minimize the expenditure. At the same time, my requirements should be met, not at the cost of my requirements. Now, what are the basic criteria which we normally want to minimize or maximize? Let us talk from a mechanical point of view. When we are manufacturing a component, there are so many things which are going as input to the making a product. You take a washing machine. There are so many components which are going into the washing machine. Or let's say you are making washing machines. You are making in a single factory, you are making number of appliances. Now what should be the combination of, what should be the quantity of each appliance, so that your profit is maximized? I want to maximize my profit, but there are different types of products I am making in the company, in the factory. Each is contributing differently to my profit. Let's say if a washing machine is made, I am making, let's say 5,000 rupees per machine. I make ceiling fans also. I make table fans also. Maybe I make some motors also. So what should be the combination? Now one very simple solution will be that I make the components only those products which are giving me maximum profit. Washing machine is giving me maximum profit per component, per unit of product. So one solution is that I make only washing machines. But that is not desirable. I have a constraint, because in the field of ceiling fans, table fans, motors, I do not want to be out of the market. So what I have, I put a constraint that okay, minimum 300 ceiling fans I should make. Right? I don't want to go out of market in any particular component, because today my washing machine is selling, maybe tomorrow there will be a lot of demand for ceiling fans, and I have invested into ceiling fan equipment, manufacturing of ceiling fan equipment. So I do not want to go out of market in that particular product. I want to continue making all the products, but at the same time I want to maximize the profit also. So what should be the optimum combination? What should be the optimum combination of the products or the components which I have to make, so that I meet the minimum requirements, I don't go beyond the maximum limit also. Let's say I cannot maybe sell more than 10,000 washing machines in a month or in a year. So I should not produce more than 10,000 washing machines. But my production capacity is there. Spare production capacity will be there. So that means I should produce something else. What should be produced? Where my profit should be maximum. That can be one criteria. Second can be that my cost should be minimum. Right? So I have to decide. What I normally say is that optimization is basically a mathematical solution. It is a mathematical solution where you try to minimize or maximize some output, some outcome. Now I have to decide. I have to decide what I want to maximize or minimize. Let's say I talked about plant layout. I want to minimize the distance traveled between the machines. Now, if you are familiar with mechanical engineering manufacturing processes, you are making many components on the machines. Same set of machines is there, and the operation sequence in each case will be different. Right? So that means if you are making a mix of components, the total time required or the total cost or the total distances traveled in each case will be different. So what I have to do? I have to find a solution. I have to find a solution where the total cost or the total transportation time is minimum. What should be the sequence? Because I have to manufacture different types of products or components. So I need to have a mechanism where I should know what is my target, what I want to do. Because we are all mechanical engineers, we are all engineers, I'll say. We do one problem, that is a traveling salesman problem. What is that? You have a person, he has to cover a number of cities, maybe 4 cities, 5 cities. We have to, that is the simplest problem. Then we want to plan a sequence of his tour, of his travel, that the total time taken or the total distance traveled by him is minimum. That is a simple problem, simplest problem which we do. And there are mathematical solutions for this. We have all studied traveling salesman problem. So one is that we should be very clear what we want to do. What I'm talking is that you want to minimize the cost, you want to maximize the profit, right? You want to minimize the production time, and you want to maximize the profit also. If you want to minimize the production time, maybe you have to use costlier machines. Instead of a conventional lathe, you have to use a CNC lathe. So there's a conflict. There's a conflict in this case. I want to minimize the production time as well as I want to maximize the profit. So these are called multi-objective. I have multiple objective now. I have two objectives which I want to fulfill. क्या क्या है? दो ऑब्जेक्टिव हो गए मेरे. One is that I want to maximize the profit. At the same time, I want to minimize the production time. But conflict है. Conflict क्या है? कि अगर मुझे प्रोडक्शन टाइम मिनिमाइज करना है तो मेरे पास जो सीएनसी मशीन है उसके यूज करना पड़ेगा जिसकी कॉस्ट ज्यादा आ रही है मुझे. I am trying to minimize the time, but at the same time, I am increasing the cost of production. So what is happening? My profit is getting reduced. So we'll discuss over the week. We have full week where we'll probably come across these circumstances depending upon the expert who is from which field he'll talk. So let us see what is the formal definition of optimization. It says optimization is the mathematical discipline which is concerned with finding the maxima and minima of functions possibly subject to constraints. Now let us see. Maxima or minima we have discussed. That you want to maximize something or you want to minimize something. Minimize means I wanted to minimize the distance traveled by a traveling salesman. Maximize, I want to maximize the profit in a particular situation. Then he says possibly subject to constraints. I have talked about a product mix where I said that given the liberty, given the freedom, I will produce only washing machines because washing machine is giving me maximum profit per unit of product. Per machine मुझे maximum profit है. So given the liberty, I will try to produce only washing machines. That means I can maximize my profit. जिस समय मेरे पास कोई कंस्ट्रेंट नहीं है, मैं जितनी मर्जी बनाता रहूं, बट कंस्ट्रेंट है मेरे पास. कंस्ट्रेंट क्या लगी मेरे पास कि 10,000 से ज्यादा नहीं बना सकता, क्यों? तो बिकती नहीं है उससे ज्यादा. I am not able to sell those more than 10,000. That means एक तो दो कंसेप्ट मैंने आपको इंट्रोड्यूस की. एक तो है अनकंस्ट्रेंट, यू डू नॉट हैव एनी कंस्ट्रेंट. सेकंड इज कंस्ट्रेंट. I have a constraint. I have constraint. What is the constraint? That I cannot produce more than 10,000 washing machines, but I have spare capacity in the plant, where that means I need to produce more of other components. 10,000 की लिमिट लगा दी मैंने इसके ऊपर. And when I come to a optimal solution for this problem, maybe मैं 10,000 भी ना कराऊं, मैं 8,000 पे बंद कर दूं. So एक कंस्ट्रेंट ये हो गई. दूसरी कंस्ट्रेंट क्या हो गई? That I have to make minimum 300 ceiling fans. वो मेरी रिक्वायरमेंट है to remain in the market. So एक मिनिमम होगी मेरी 300, बट उसके बाद मेरे पास मैक्सिमम भी है कि 1200 से ज्यादा सीलिंग फैन नहीं बिकते मेरे. So I have to have a limit on minimum as well as maximum number of a particular type of product. Right? एक कंस्ट्रेंट हम लगाते हैं. Let's say X1 is the number of washing machines, X2 is the number of ceiling fans. एक कंस्ट्रेंट हम लगाते हैं कि they will be both non-negative. Non-negative मतलब माइनस क्वांटिटी नहीं हो सकती इनकी. क्योंकि जब मैथमेटिक्स से हम सॉल्व करते हैं, मैथमेटिक्स तो हमें माइनस क्वांटिटी भी दे देगा अगर हम अनकंस्ट्रेंट छोड़ देंगे इसको। अगर हम उसको माइनस वाली कंडीशन नहीं लगाएंगे तो वो तो माइनस भी दे देगा। तो हमने एक कंस्ट्रेंट लगानी है कि नो, x1 एंड x2 आर बोथ नॉन नेगेटिव एंड नॉन जीरो। या हमने कंस्ट्रेंट लगा दी कि x1 इज ऑलवेज मोर देन 400 एंड x1 इज लेस देन 10,000। 400 से ज्यादा वॉशिंग मशीन बनानी है और 10,000 से कम बनानी है। दो कंस्ट्रेंट हो गई मेरे पास। सिमिलरली आई कैन हैव कंस्ट्रेंट्स ऑन द अदर इनपुट्स। सो जो ऑप्टिमाइजेशन है, इट इज बेसिकली ए मैथमेटिकल टूल। एप्लीकेशन इज इन engineering and non-engineering areas both. Now, before we can think of optimizing something, we should be very clear that what we want to do. किस चीज को मिनिमाइज करना, किसी को दो ही चीजें हो सकती हैं ऑप्टिमाइजेशन में, या मिनिमाइज या मैक्सिमाइज। फर्स्ट रिक्वायरमेंट इज दैट we should be able to express the objective of our work in a mathematical form. Mathematical form in terms of what? In terms of the entities which are affecting the outcome. अगर मैं वापस अपनी प्रॉब्लम पे जाऊं, प्रॉफिट कौन हमारा इफेक्ट कर रहा है? Profit is being affected by number of washing machines made and number of ceiling fans made and number of motors made. So I should know how much is the contribution of each product on the profit of the organization, right? So that means I should be able to write that objective more than one factors affecting. तभी प्रॉब्लम बनेगी। अगर सिंगल फैक्टर है फिर तो बंद करते जाओ, वॉशिंग मशीन बनाते जाओ जितनी मर्जी, राइट? So unless we have it, then we should be able to write them in mathematical form. So if you look at this first screen, optimization is the mathematical discipline which is concerned with finding the maxima or minima of functions possibly subject to constraints. It can be applied in all areas. Engineering में मैंने बहुत कुछ cover कर दिया. All engineering areas. Architecture वाले भी करते हैं. Nutrition, you want to get the some outcome out of some food values. So what should be the proper mix? Civil engineering वाले करते हैं. Concrete strength है, right? When they design concrete mix, they have to decide what should be the components of the mix to get the, let's say, maximum strength, compressive strength. So they can decide. They can find out what should be the quantities of each of the inputs so that they get the maximum or the desired strength. Economics, transportation we had discussed. Now let's see what is this. The first thing we should know in optimization is that we have to write a function, we have to write a mathematical equation which we call it as objective function. Objective function is minimize or maximize what? Profit or something else. It can be, because simplest is profit and cost, right? But it can be anything else. Distance traveled, right? Time taken. Even in mechanical, we did a study on to maximize the tool life of a cutting tool. because there are so many factors which are affecting the life of the cutting tool. So you should be able to write that into a equation in terms of, let's say, cutting tool life is, let's say, T. Now it depends on what? It depends on depth of cut, feed rate, and RPM, cutting speed, or V. If I am not able to write the tool life in terms of these parameters, V, F, and D, I cannot solve. So what I do is I have to write a equation that, okay, T is V raised to power something, F raised to something, and D raised to power something. So I write an equation which is called objective function, which is a function of, objective function is a function of the variables which affect the objective function. जैसे टूल लाइफ वाली एग्जांपल पे आ जाइए. I will write tool life, cutting tool life in terms of V, F, and D, and they may not be affecting it in the same proportion. So I write, okay, V raised to power A, F raised to power B, and D raised to power C. I want to find those values. Now I have written that objective function. So that means there is a function which is, there is a function of n variables, n means 1, 2, 3, 4, any number variables, which is affecting the objective function. Subject to constraints. Subject to some constraints. Now it is not always that you have a constraint, a set of constraints. But let us see. It says minimize f of xy. That means there is a function which is dependent on, this is a, where x and y are the two variables which are affecting that function, and it says minimize fx y is equal to x square plus 2y square. That means there is a function fx is equal to x square and 2y square which I want to minimize or maximize, whatever. So I can write this like this. And x should always be greater than 0. There is no constraint on y. Y can be anything. But we have put a constraint here. So this is a constraint minimization problem. Just see this. Minimize. Minus 2 is less than x is less than 5. And y is equal to or greater than 1. So what has happened here? I have put two constraints on x here. There are two constraints. That means minimum value x can have is minus 2. Not even minus 2, it should be greater than minus 2. And it should be less than 5. So it has to be translated into two constraints. That means x is minus 2 is less than x and x is less than 5. And y is equal to or greater than 1. Or the third type, just see, x plus y is equal to 2. So that the sum of x and plus y should be 2, but there is no constraint that there should be positive or negative. Right? So what is the objective function here now? Objective function is minimize x square plus 2y square. Subject to what constraints? Constraints may be what we called as equality constraints, where you have x plus y plus is equal to 2, or inequality constraints where it is equal to, less than, equal to, greater than. Okay. Let's say we want to optimize the minimum of this function. Some function has been plotted. Some function has been plotted. So where is the minimum of this? So minimum will be the lowest point. But if you see this x-axis, there are 2 points which are below that point. Now let's say we start at left hand side. Okay, let's say we start at the right hand side of the curve. How the optimization will work? It calculates it gives some values to the variables x and y. Let's say we go to that previous equation. It will give the values to some values to the x and y variables and calculate the objective function. And it will increment the variables, again calculate depending upon the criteria we have given. I'll talk to you about that also. It will give you the final results. So what happens here? There is something called termination criteria in optimization. So what is termination criteria?
When the optimization stops, whether it's
When the optimization will stop. Right? Optimization will stop at a given criteria, which is given, which is we give, as a user we give, which is called termination criteria. So termination criteria can be difference between the two values of objective function. Let's say I am trying to maximize the profit. मैं कहता हूं कि अगर 1000 रुपए कम प्रॉफिट में डिफरेंस है, जो पहले सेट पे आया था, कुछ वैल्यूज हमने वॉशिंग मशीन और सीलिंग फैन प्रोडक्शन की निकाली थी, और जो नेक्स्ट स्टेप में अगर 1000 से कम डिफरेंस आया तो इसको टर्मिनेट कर दो. इसका मतलब मुझे इसके बाद काम करना, बिकॉज व्हाट वी प्रेज्यूम दैट whenever you are working on the computer, that also cost is there. So minimize the working cost, analysis cost. हम कहते हैं कि ओके, जब 1000 से कम डिफरेंस हो गया तो terminate the optimization process, और वो वैल्यू मुझे दे दो क्या है, x1 और x2 की, सीलिंग फैन कितने बनने चाहिए और वॉशिंग मशीन कितनी बननी चाहिए. So termination criteria can be the difference between the two consecutive values. If you have seen, if you have gone through the optimization process, it is basically an iterative process. Iterative process means it starts with some value, calculates the objective function, increments or decrements the values of the variables, या तो बढ़ाता है या उनको कम करता है, and it again calculates the objective function, and it goes on repeating. It is a iterative process. So एक तो है कि जब हमने दो वैल्यूज में डिफरेंस हमें पता चल गया कि इससे कम हो गया, अब डिफरेंस, अब 1000 रुपए से ज्यादा प्रॉफिट नहीं मेरा बढ़ रहा, तो मैं कहता इसको टर्मिनेट कर दो, चलो छोड़ो ठीक है. दूसरा है कि नहीं, मैं तो देखना चाहता हूं कि आगे जाके कितना होता है. मैं कहता हूं कि नहीं, जब तक मेरी 500 इटरेशन नहीं होती मैं इसको चलने दूंगा. So either it is number of iterations, that 1,00,000 इटरेशन, क्योंकि कंप्यूटर कर रहा है, मैं नहीं कर रहा, तो मैं कहता हूं 1,00,000 इटरेशन होंगी तब तो उसके बाद बंद कर देना, जो भी वैल्यू आएगी मुझे एक्सेप्टेबल है, और उसमें से जो मिनिमम होगा वो मुझे दे दो. ऐसा नहीं है कि 1,00,000 मेरा 600 के बाद मेरा x1 x2 की वैल्यू आई थी जो मिनिमम थी, उसके बाद मेरी बढ़ गई 1,00,000 पे चला गया मैं, फिर बढ़ गई 1,00,000 वाली वैल्यू नहीं मुझे चाहिए, मुझे तो जो मिनिमम वाली थी वो स्टोर करनी चाहिए. तो वो बता देगा कि ठीक है कि 650वीं इटरेशन पे मेरी वैल्यू इतनी आ गई थी, that is okay, that I will store, and that the system will give me that okay, these are the optimal values and this will be the profit at this optimal value. So termination criteria will be either number of iterations or the difference between two consecutive values of objective function. Now coming to this, अगर आप राइट साइड में देखें, एक जगह पे मिनिमम हो गया ये, है ना, लोएस्ट उस पे आ गया, तो जब लोएस्ट पे आ गया पॉइंट पे, हमारा मिनिमाइज कर रहे हैं हम, लेट्स से ट्रेवल टाइम मिनिमाइज कर रहे हैं, तो यहां पे ब्रेक हो जाएगा हमारा ऑप्टिमाइजेशन प्रोसेस, ब्रेक हो जाएगा, बिकॉज इससे अभी नीचे नहीं हो रही, वैल्यू नीचे नहीं जा रही। बट यू एक्चुअली सी, अगर आप लेफ्ट साइड पे उस लाइन को फॉलो करते आओ तो उसकी वैल्यू तो कम है, वैल्यू इज लेसर देन व्हाट द वैल्यू what we have got. So there are more than one minima here. The right side minima, because it will depend which one will come first. If you start from left side, your initial values are starting from left side वाला minimum पहले आ जाएगा. If you start from right side वाला minima पहले आ जाएगा. So let's say you start from right side to make these things clear. So right side वाला minimum पहले आ गया, but it is not the actual minimum value. Minimum value तो left side वाली है. But the behavior of the curve is, behavior of the function is like this. So what happens? हमारा तो वहीं पे terminate हो गया system. So this right side minimum जो है value, that is called local minimum. You may have more than one local minimas. Whereas जो right side left side वाला minimum value है, उससे कम कोई नहीं है. आप पूरा फंक्शन स्कैन कर लोगे बिटवीन द गिवन रेंज, है ना, बिटवीन द गिवन रेंज ही है ये भी, -4 to 4 ही है. So between the given range, there is no value which is lesser than the minimum value on the left side. So this is called global minima. We should be very clear that what is local minima and what is global minima. जब हम optimization use करते हैं, because many of you will be using this optimization for your research purposes. Maximum problem will be that you will be caught up in a local minima. How to get out of this? That is the biggest problem. You are held up and the computer gives the value and you know it is not the value. When you are searching something, you know what should be the value. Approximate value तो हमें पता ही होती है. So but you are held up somewhere. So the problem is how to get out of this. इससे बाहर निकलेंगे तभी ऊपर जाएंगे दोबारा. So we have to find out some ways of getting out of this. Either you take a sudden jump, या आप इंक्रीमेंट बढ़ाओ, कुछ ना कुछ तरीका निकालना पड़ेगा. Okay, this is the mathematical treatment. We will not go into mathematical treatment at this point because I want to be on the practical side only. So what we have is, in optimization, what we have is, we have an objective function, we have set of constraints. Now, if the objective function as well as the constraints are linear, linear means any of the variables doesn't have power more than 1. So it is 2x plus 3y, or 5x plus 6y, or 10x plus 10y plus 20z. Neither the objective function nor constraints, or we say objective function as well as constraints both are linear. That is called a case of linear optimization, right? That is called a linear optimization, for which simpler method, which will be discussed in the afternoon, simplex is used for, or linear programming is used for solution of linear equations. If the equation is simple, we have been doing it. We have been doing graphical method of solution of two or three equations, because the variables involved were only x and y, and we have two equations or three equations, so we could do it manually. But where the number of variables is, let's say, any number, n number, and maybe they are not always linear, it may not be possible to solve all these equations manually. So what has happened? So computer has come into picture, and computer has helped because of its faster solution capabilities. So जब जैसे जैसे complex होती गई problem, manually it may not be possible. People have been doing earlier, but number of variables बढ़ने से complexity of the system बढ़ने से computer has helped. People have written their own programs. There are commercial programs available. Let's say in MATLAB, you have an optimization toolbox where you have to do, what you have to do is you have to just give your equation and the constraints, your objective function and constraints, and it gives you the outcome. It gives you the solution. It gives you the optimal value as well as values of variables at that optimal value. So depending upon the complexity of the problem, you have to choose the tool. So one is that you have a linear programming problems, linear optimization problems, where the equations are involved in objective function as well as constraints are linear. If you have either objective function or any of the constraints or all of the constraints or objective function as well, एक भी या सारे या any number are non-linear. That means the power is of any of the variables in the equations is more than one. It is called a non-linear optimization problem, and the treatment is different. Solution method is different, right? Basically, this is a mathematical treatment, which when we talk about maxima and minima in mathematics, this is done at the first derivative and second derivative. So at local maxima or local minima, first derivative of the function is 0, and if second derivative of the function is more than 0, if it is less than 0, it is local maxima. So let us not go into this detail at this stage. Maybe somebody will discuss all this. Now let us see how the system works. Once you have written the objective function and constraints, what you do is you normally there are ready-made programs available, or if you are very good in programming, you can write your own program. People have been writing their own programs also. The advantage of writing your own program is that you have a better control on the working. I myself experienced this problem because sometimes you are stuck up somewhere in the program when you are using a ready-made program. What will happen? Sometimes the denominator will become 0. So division by 0 is not possible. So the program, either the computer hangs or the program terminates. But if you have written your own program, you know what is happening. You can always say that if denominator becomes 0, give it a small value. The program will never terminate. So people have been writing their own programs also. So what it needs is that you need to give a starting value. There are some techniques where starting value also the system will automatically find. But if you have an idea about a starting value, means starting feasible value. Starting feasible value क्या होती है? Where all the constraints are satisfied. If you say that x should be more than 3, x should be, and let's say you say x is more than 3 and less than 10, so x value should be between this, right? Similarly, y, z. Normally, when we have to write the program, we do not write x, y, z. We write x1, x2, x3 because it is computer is more convenient to work with these values, because you just write an array and put the values in that array. So you need a starting value, starting point, or starting physical point where you want to start. Then you want a convergence criteria. What will be by termination criteria? Termination criteria can be either the difference in the two consecutive values or the number of iterations. How many times the system should work, program should work. That I can give. Before that, I should define the objective function and constraints. Another parameter which I need to give is the increment value. It may have inbuilt increment value, but if possible, I should give an increment value that, okay, x variable, x1 variable, x2 variable, x3 variable, what should be the increment? What should be the increment in each value? Okay, एक value लेके हमने calculation कर दी, उसके बाद next value जब calculate करनी है, what should be the increment? How much x1 should be incremented? Whether it should be incremented or decremented. That who will decide? Probably that the program itself will decide. Sitting outside, we cannot do that. We have to give these three values, and rest of the things the program will do. It will give you it will do the iteration. It will check at each step. Let's say it will calculate the objective function and store it. It will increment the variables, calculate the objective function again, and compare it with the first value. So it can say, okay, this is the minimum value till now. So if the next value is less than the previous value, so it will store it as the minimum value. Again increment the variables, and calculate the objective function. Okay, this is just basics of optimization. There are many techniques which have been used. One is the classical techniques like linear programming, geometric programming. Any other programming techniques you have? You know it? Integer programming, dynamic programming. Okay, let us see. Classical optimization techniques, that means there are other optimization techniques also, which are modern techniques which decide in which direction they have to go, and they are not stereotype techniques. They will find out the next step themselves, right? We'll come to it. Let's say the classical optimization techniques are useful in finding the optimum solution or unconstrained maxima or minima of continuous and differentiable functions. One of the conditions in mathematics is that the function should be differentiable at that point. So I said we are not going into the mathematics at this point of the optimization. These are analytical methods and make use of differential calculus in locating the optimum solution. The classical methods have limited scope in practical applications, as some of them involve objective functions which are not continuous and or differentiable. Because we may have in practical applications, the function may not be differentiable at a particular point. Discontinuous functions also we may have. Three main types of problems can be handled by classical optimization techniques: single variable functions, multivariable functions with no constraints, and multivariable functions with constraints. Constraints may be both equality and non-equality constraints. These are the numerical methods. Linear programming. Linear programming will be only for linear optimization problems, where both the objective function as well as the constraints are of the linear type. Integer programming, where all the variables will take integer values. Decimal values nahi ho sakte isme. Quadratic programming allows the objective function to have quadratic terms, while set A is a design variable space. Must be specified with the linear equalities and inequalities. Nonlinear programming studies the general case in which the objective function or the constraints or both constraints contain nonlinear parts. Even quadratic programming and integer programming are also nonlinear programming. इसमें भी क्वाड्रेटिक में तो 2 पावर होती है, raised to power 2. Stochastic programming studies the case in which some of the constraint depends on random variables. Dynamic programming, as somebody said, studies the case in which the optimization strategy is based on splitting the problem into smaller subproblems. Combinatorial optimization is concerned with problems where the set of feasible solutions is discrete or can be reduced to a discrete one. Infinite dimensional optimization studies the case when the set of feasible solutions is a subset of an infinite dimensional space, such as space of functions. And constraint satisfaction studies the case in which the objective function f is constant and you manipulate the constraints. What is hill climbing? That means you go on incrementing. Is a graph search algorithm where the current path is extended with a successor node which is closer to the solution than the end of the current path. That means you calculate the solution, objective function, and if you are going in that direction where you are getting the better results, then only you extend in that direction, otherwise go in another direction. In simple hill climbing, the first closer node is chosen, where in steepest ascent hill climbing, all successes are compared. Anyway, hill climbing is a complete optimization area where you have number of variables, number of alternatives at each point. है ना? जैसे tree है, उसमें you have alternate methods, alternate paths available. So which path you should take? You do not know which path will give you the best solution. But you calculate the possible values along each path, and the path which is giving you better results, you follow that path. है ना? 4-5 ऑप्शन है आपके पास, 10 ऑप्शन है. So you try to go along each option. जो ऑप्शन आपको बेस्ट रिजल्ट देती है, which is taking towards your goal may be minimize or maximize. अगर उस डायरेक्शन में लेके जा रही है, उस डायरेक्शन में आप नेक्स्ट स्टेप लोगे. Simulated annealing, basically it is from the annealing process that you give a treatment और उसके बाद shock. Okay. Heating and controlled cooling, so not shock, controlled cooling. That means you take it to a point, then go down slowly. Please don't worry about all these terms, because you have to just know that these are terms are available, because we during this week we will not talk about these terms again. We will restrict to MATLAB based programming only, right? So because this is just to introduce, because you should know all these terms. In the simulated annealing method, each point of the subspace is compared to a state of some physical system, and the function to be minimized is interpreted as the internal energy of the system in that state. Therefore, the goal is to bring the system from an arbitrary initial stage to the state with the minimum possible energy. Possible energy means minimum possible objective function only. This genetic algorithm has been used, very widely used. GA it is called. Very widely used, lot of research work has been done, and there has been very wide engineering applications of GA. It is called evolutionary algorithm. That means it evolves. It evolves. It is basically, it works on a child-parent combination, that good parents will produce a good child. So it takes a combination of the parents to the new value. They call it a child. जो parents की values की combination लेके उसकी एक नई next value बनाता है, right? A lot of work has been done. It is a very simple technique also. There are many variations in GA which has been discussed. So genetic algorithms are a particular class of evolutionary algorithms that use techniques inspired by evolutionary biology, such as inheritance, mutation, selection, and crossover. Genetic algorithms are typically implemented as a computer simulation in which population of abstract representations of candidate solution to an optimization problem evolves towards better solutions. The evolution starts from a population of completely random individuals and occurs in generations. In each generation, the fitness of the whole population is evaluated. Multiple individuals are stochastically selected from the current population and modified to form a new population. That is what I said, child-parent combination. The new population is then used in the next iteration of the problem. That means from the previous solution, you take number of candidates and take their characteristics and start with a new solution, new set of variables. Another method is ant colony optimization. You see, these are nature-inspired methods. Nature-inspired means, if you have seen this honeybees, when they fly, honeybees, they fly, they take a particular route. Nobody has taught them optimization. Optimization has come from them. When they return to their colony, they take a particular route. Similarly, you can see that you have a flock of birds flying in the sky. Just see the shape of that flock. That will be aerodynamic shape. Least resistance. Least air resistance will be there to that. So nobody has taught them. We have learned. We have learned from them how to make a aerodynamic body, how to make aeroplane. आप देखना ऐसे ऐसे उड़ेंगे वो, है ना? So in the real world, ants wander randomly and upon finding food return to their colony while laying down pheromone trails. मतलब ये है कि they leave small particles in the air when they come back, and the next batch, next ant, honeybees will come only following that path. कहां से पता चलेगी? जो फेरोमोन पहले छोड़े हैं मक्खियों ने उसी को फॉलो करके हैं pheromones. If the other ants find such a path, they are likely not to keep traveling at random, but instead follow the trail laid by earlier ants, returning and reinforcing it if they eventually find food. Over time, however, the pheromone trail starts to evaporate, thus reducing its attractive strength. The more time it takes for an ant to travel down the path and back again, the more time the pheromones have to evaporate. The short path, by comparison, gets marched over fast, and thus the pheromone density remains high. What it wants to say is, every bee, when it comes back, leaves pheromones. जो longer path वाले pheromones हैं, that may not be traversed by other bees, so वो तो evaporate हो जाएंगे. बट जो शॉर्टर पाथ पे आएंगी बीज वो और फेरोमोन छोड़ती जाएंगी, सो दैट विल बी गेटिंग स्ट्रॉन्गर एंड स्ट्रॉन्गर. जो वेपोरेट हो गया, दैट विल नॉट बी विजिबल, दैट विल नॉट बी सेंसिबल टू द एंड्स व्हिच आर कमिंग आफ्टरवर्ड्स. जो शॉर्टर रूट से आई थी उस पर तो कई बहुत सारी बीज आ गई, तो वो वहां पे रहेगा, उसी पाथ से आएंगी दोबारा फिर सारी. So that probably that aspect has been used in ant colony optimization. Pheromone evaporation has also the advantage of avoiding the convergence to a locally optimal solution. If there were no evaporation at all, the paths chosen by the first ants will tend to be excessively attractive to the following ones. In that case, the exploration of solution space would be constrained. So this is a nutshell ant colony optimization. Now let us discuss a small problem. Let's try to wrap up. What is optimization? Optimization is that means when you have a combination of resources, and that is my personal view, that there should be a restriction on the resources. Resources should not be available in abundance. You have a constraint on resources. Resources क्या है? टाइम पर कंस्ट्रेंट है, प्रोडक्शन कैपेसिटी पर कंस्ट्रेंट है. आपकी जो प्लांट लेआउट के लिए या चिप लेआउट के लिए स्पेस है, उस पे हमारी स्पेस है, अपनी कंस्ट्रेंट है. So when you want to have a combination of resources to minimize or maximize the outcome, that is optimization. और optimization के लिए आपको you need to have a objective function, you need to have a set of constraints. Unless we are able to model it into a mathematical form, we will not get the correct results. The accuracy of the results will depend upon how accurately we have been able to model the problem into objective function. ज्यादातर क्या होता है कि अगर हमने ऑब्जेक्टिव फंक्शन हमारा प्रॉपरली रिप्रेजेंट नहीं कर रहा हमारे, यूजुअली तो सिंपल प्रॉब्लम्स मैंने की हैं, वी मे हैव कॉम्प्लिकेटेड इक्वेशंस रिप्रेजेंटिंग द फिजिकल फिनोमेना. अगर फिजिकल फिनोमेना को हमने मैथमेटिकली प्रॉपरली रिप्रेजेंट नहीं कर सके, तो वी आर नॉट लाइकली टू गेट ए वैलिड रिजल्ट व्हिच कैन बी फिजिकली यूज्ड. सो ऑप्टिमाइजेशन starts with the objective function, what we want to do. We should be able to decide and write it mathematically. We have been doing optimization graphically also, but that will be for very simple problems. Now we are talking about computer-based optimization. For that, we need a mathematical function. So optimization can be constrained and non-constrained. Optimization can be linear and non-linear, depending upon what type of objective function and constraints we have. Now we talked about global and local minima and local maxima, and we have to think, depending upon the situation, how to get out of this. This is very typical situation where you will be, many times you will be held up, that you will not be able to get out of the, your program may terminate, but you know you have not reached the global minima or maximum. Now I worked on a problem that is basically maximization of cutting tool life. I introduced it earlier also, that we had T is equal to, tool life is equal to V, F and D raised to some powers. Now this becomes the objective function. Objective function is that maximize T, which is in the form of a equation V raised to power A, F raised to power B and D raised to power C. Now what are the constraints now? What can be the constraints? Constraints are that I have a limit on the V, or V I can convert in terms of pi d n. D is fixed, so I can convert V in terms of n RPM, which is controllable, directly controllable. So I have a limit on the RPM. So one of the constraints is that I can have minimum RPM of, let's say, 40 RPM and maximum of 4000 RPM. So I say, okay, n is more than 10 and n is less than 4000. Two constraints I have put on n. Similarly, I have put a constraint on F, feed rate. I can put, depending upon the material I have to cut, cutting tool material, machine availability, what is the machine I will be using, and what is the capability of the machine, what can be the maximum and minimum feed available on the machine. Let's say maximum feed available on the machine may be very high, but the recommended value for a particular cutting tool and work material may be limited. I can put a limit on that. So I can make constraints for this. Similarly, depth of cut, I can put a constraint based on the system integrity. जो machine है मेरी कितनी depth of cut ले सकती है. So these are the direct constraints I have put. V and V, F and D पे मैंने दोनों साइड पे minimum and maximum पे constraint लगा दी, linear constraints लग गई. But at the same time, I know that my depth of cut and feed do affect the surface finish. So if I can write a equation for surface finish in terms of F and D or Fn and D, RPM, depth of cut and feed rate, that should also be satisfied, because maybe I need a good surface finish. I should need a surface finish limited by some number. इससे ज़्यादा नहीं होनी चाहिए मेरी surface roughness. So I write a equation. Let's say I say surface roughness is F square by F8D. Please don't take it. Just some hypothetical value I have said. That okay, that my surface finish F square by 8D should be less than 0.5. Some value. That should also be satisfied. Right? Then maybe there are some additional things. You have 10 machines available. I want the cost to be also minimum. Which machine should I select? There are 10 machines which are physically available in the factory, but 2 of them are out of order, or 2 of them are already loaded, which are not available. My system should not consider those machines at all. So all those factors can be taken and your optimization problem can be solved, which I did solve. There are different techniques which you can use, and this week we will concentrate on, in addition to linear programming, we will concentrate on how to use MATLAB for solving optimization problems. Then maybe, if possible, we will have a session on ANSYS also. That should help all of you in solving some problems. Another thing I want to tell you here is that in 1 week, we will introduce you to solution of optimization problems through MATLAB. If you keep working, if you go back and start working on MATLAB at your places, then you will learn. Otherwise, I'm sure within 15 days, you will forget everything. So my session comes to end here now. Any questions you have? Let us have some questions.